Okay, I'm not going to do all of the beginning questions because I think they're pretty basic and you should know how to change back and forth between logs and exponential. Just remember, a log says the word log or ln, and an exponential obviously does not say the word log. So what you have to do is you do have to be familiar with the conversion from log to exponential. So that's what I want to go over first, because it's going to be useful when we do our other problems. So we've got log base b of x is equal to y. So if I want to convert this into the other form, I can bring the base down and I make it kind of big. And you can kind of see this part right here. It looks like it's already in an exponent, but it actually isn't. But we use that fact when we do the old switcheroo right here. So the y comes to where the x is, which now it looks like the exponent, and then the x goes to the other side. And guys, you'll see problems where the equal side is over here. Scribble it out and just move the stuff over there so it looks like this. So it's not that big a deal. So the stuff that I wanted to talk about is number 14. There was all kinds of people that had questions on number 14. It says, describe the relationship between y equals log 4 of x and y equals 4 to the x. So here's what we got. I can't compare them when they're in different forms, so I'm going to make the log into the exponential form. So I'm going to take this 4. Oh, and remember, if it's not on the right side, I can just kind of scribble it out and put it over here so I'm not all weirded out by the question. So I have 4, and then these two things switch. So I have 4 to the y is equal to x. Now, if you just compare this to this, they almost look exactly the same. The only difference is the x's and y's are in different places. So they're basically reversed. We call that inverses. They are inverses of each other. So all the features that are true about inverses, like the x's and y's switch, so the domain becomes the range and the range becomes the domain, they're all true. Now, some other things that you should memorize is that logs have a vertical asymptote. And your vertical asymptote, I'll put it as VA, it's always x equals. Now, since they're inverses of each other, that means that the other one has a horizontal asymptote, and that's always y equals. And if you want to come up with the actual numbers, you would use, for the logs, you would use whatever's inside here with the x. All you do is change the sign. So it would be the opposite number of what's inside the log. For the horizontal asymptote, you would use the k. So it's whatever the k value is, which we always find at the end. So those are just some quick key points to remember about graphing logs and exponentials. So hopefully you can remember that before the test. I'm going to clear this out and start from the beginning. So this part right here is in a section on the quiz that says, describe the process to solve an exponential equation when the bases cannot be made the same. Actually, I read the wrong one. This one's number 15. Describe the process to solve an exponential equation when the bases can be made the same. So that's a huge clue in the review, and unfortunately, it's not going to say that on the test. On the test, you just got to go through the scenarios. There's 2 scenarios. The bases are the same, bases are not the same. If they're not the same, you try to make them the same. So looking at all 4 problems, none of these have the same base. This one has 7 and 49. That's not the same. You got 25 and 125, you got 4 and 8, and you got 9 and 27. So we're not starting off with anything that has the same base, which is the easiest form of the problem, because then you just cross them out and solve what's left. So we have to change the base to make them the same. Now, the biggest thing I saw over the last 2 days in terms of the mistakes that people were making is like in number 16, for example. People were trying to turn this 7 into a 49. No, you don't want to do that. When we change bases, we want to make bigger numbers smaller. So we actually want to change the 49 into a 7. So 49 into a 7 would be 7 squared. Then you have 7, 2 to the x minus 3. Now you can cross out the 7s. So you have 2x minus 3 equals 2. And this is all algebra 1 stuff. Matter of fact, I'm not even going to finish solving that. You can solve that problem now. So all I'm going to do is show you how to convert. And once it gets to the equation part, you can solve it yourself and check the answer in the back. So number 17. For number 17, you try to turn the bigger one into the smaller one. Now the only problem with that is when you square 125, you're already at 625. So I can't turn 25 into 125. So the next option is to see if you can change the 25 to something even smaller, which you can. So 5 squared gives you 25. And don't forget, this had some stuff up here, so you put it in parentheses and just put it right back. So now on the other side, we check to see, could I turn a 5 into a 125, which you absolutely can. It's a 3. 5 to the third is 125. It already had an x, so we put it back in parentheses. Now we can cross out the 5s and solve what's left. And guys, again, at this point, you need to know how to solve this. I'm not going to finish solving that. You can solve it yourself. Distribute, get all the x's to one side, and then you got your answer. Number 18. So again, we're trying to change the big one to the small one. So we just start off with a 4, but 4 squared is already 16. So it doesn't work. It's an 8, so I can't make an 8. So what I do instead is I change the 4 into 2 squared, and then it already had stuff up there, so I just put it in parentheses. And then on the other side, I check to see if I can make the 8 into a 2, which you absolutely can. So it's got a 3. It already had stuff up there, so we put it in parentheses. And now we can cross out the 2's, and here's what we have left. Negative x minus 3 equals 3, parentheses, x plus 4. Again, guys, this is Algebra 1 math now. Once you cancel the bases, you should know how to solve this. You have to distribute. You have to get all the x's to one side, get all of the numbers to the opposite side. So I'm not going to solve it. You can solve it, and then check the answer in the back. Number 19, sorry. So again, change the big one to the small one. So can I turn it into a 9? 9 squared is already 81, so I can't turn it into that 27 right there. So I get rid of that, change the 9. So 3 squared. It's already got stuff. So you got 3x minus 1. The other side is now 3 to the third, and it has x on it already. So we can cross these out. 2 parentheses, 3x minus 1 equals 3 times x. And again, solve it yourself. Distribute, move the x's over, divide, you're done. Just make sure you're doing it right, guys. Check it in the back. Don't just write down nonsense to get it done so you can get the points. This is about practicing for the test. Okay, the next group of questions, I'm going to do these sort of out of order. This entire group of questions falls into the second category. So option number 1, try to change them to make them the same base. Option number 2, if they don't have the same base, you got to find a different way to solve it. This entire section, like let me start with number 22. I cannot turn a 40 into a 7. I cannot change 7. So that means either I need to change forms or I need to just take the log of both sides. Now I'm going to do this 2 different ways so you can see where the answer in the back comes from. In class, we worked with decimals. So I'll just show you what I showed you in class the day I had the sub. So if you can't change the bases, you have to take the log of both sides. So log of 7 to the x minus 2 equals log of 40. So the reason why we need to do this is because there's a property in logs that says if you have an exponent, you can move it out to the front. So we can take this x minus 2, put it in front of this log, which is now being multiplied by that. Log of 7 equals log 40. And then we can divide by the log of 7. And we can do that because log of 7 is just a decimal. So these cross out. And then you can already see, like, I have x minus 2 equals log 40 over log 7. Whoa, I don't want to write it like that. Log 40 over log 7. That's a decimal. And now all you have to do is add the 2 over. And then this part right here, it's all calculator work. Now in the back, they're just leaving the logs like that. They're not putting the decimals. Now I want to show you, because in the video I showed you when I had the sub, that's how I worked out every problem. But I want to show you there is another way to do it. Some people think it's easier. I don't think it's any different. It's the same thing. So if you have 7 to the x minus 2 equals 40, you can actually change forms. You can go into just the log form. So in a log form, you would go log base 7, switch these 2 guys, So then you have 40 equals x minus 2. So now you can see the x is in a place where we can just get rid of the 2. And now we would have log base 7 of 40 plus 2. And I do that parentheses just because log base 7 of 40 plus 2 is not become log base 7 of 42. Log base 7 of 40 is a decimal, and then we're going to add 2 more to that. And now there's our x by itself. So either answer, I don't care how you do it. If you look at the decimals, they are the same exact decimals. Now, as far as the rest of the explanation for this video, I'm not going to do it both ways because now I'm doing every problem twice. What I'm going to do instead is I'm just going to do it the way I did in the video the first time. So I'm going to take the log of each side. I'm going to save number 21 for last up. So in this one, log of 3 to the x is equal to log of 25. Now we can bring the x out to the front. So x times log 3 equals log 25. And now I can just divide by log 3. And you'll notice I'm not typing it in just because I'm in a hurry. It's after school and I want to go home. But I still have basketball practice, so that's why I'm trying to hurry. You guys have calculators, you have Desmos, you have the World Wide Web. You can type it in yourself. So that's what you get. The next one, same exact thing. So you got log 10 of x minus 5 equals log 17.8. This entire thing comes to the front. So you have x minus 5. Log 10 equals log 17.8. So you can divide by the log of 10. Divide by log of 10. Crosses out. So you have x minus 5 equals log 17.8 over log 10, which, by the way, log 10 is just 1. Whatever, though. You can type it in and figure that out yourself. And then we've got, let's see, add 5 to both sides. Add 5 to this. So, again, you type it in. I'm not typing anything today. 17.8 over log 10 plus the 5. So the answer, again, is just a decimal. So in number 21, there's a reason why I did this one last. If you look at 22, 23, and 24, if you look at every single base, you've got the 10, you've got the 7, you've got the 3. But when you look at the E has other stuff around it. It's got the 2 and it's got the 1. So before you do what I showed you in the other 3 problems, you have to isolate the base. So this is basic math. Add 1 to both sides first. And you have 2e to the x. Then that's being multiplied, so you divide by 2 next. So you have e to the x equals 5. Now, the thing about an e is you could still do the log to both sides. But whenever you're dealing with e, it's actually easier, get it, easier, to use ln. Do the ln of each side. The reason why is because the ln of e is just 1, and then this x just comes to the front. So basically you end up with x, because 1 times x is just x. So basically it's like ln of e just disappears. So then ln of 5, natural log of 5 goes in the calculator and you get your decimal. Okay, let's see what else we got. Okay, so now we've got logs. You've got logs galore on this page. So you have to know how to solve problems that involve logs. Actually, I'll scoot this down. We'll do these logs first. So let me scoot this and go back up. Okay, so 26, do that. It's got logs all over the place. Now, when it comes to logs, there's 3 basic formats. You either have 1 log in the problem, 2 logs in the problem, or 3 logs in the problem. So I'm looking at these, and I want to start off with number 28. 28 has some ln's in it. Ln's are just fancy logs. It's log base e. But the main point is, if you have 2 logs in your problem, and there's 1 log on the left and 1 log on the right of the equal sign, you just cross out the logs and solve what's left. So 3x plus 1 equals x plus 5. And then I am actually going to solve these ones because I want to know what the answer is. When you're working with logs, it's possible to get extraneous solutions. And I'll show you how to test for that in a second. So we get that, and then we subtract 1. So we get 2x equals 4. Divide 2, so x equals 2. Now here's what we do to check to see if it's extraneous. you don't really have to plug it in and see if they're equal. You just got to plug it in and make sure that this quantity and this quantity does not become 0 and does not become negative, because that's when you get the error in the calculator. So if I plug in 2, multiply by 3, and add 1, it's positive. We're okay there. If I plug in 2 and add 5, it's positive, so we're okay. So that's not an extraneous solution. Okay, let's see. There's another one. Yeah, here's another one. You've got a log on the left and a log on the right on number 29. So you can cross these out. You have negative 2x equals negative 3x minus 4. Get all of the x's to one side. So I'm going to add 3x here. So I have x equals negative 4. Now, when you guys look at that problem, like in class today, I had all kinds of kids like, oh, that's extraneous. No, not exactly. Just because you get a negative does not mean it's extraneous. It's when you go back and plug it into your log, that result cannot be negative. So if I plug in negative 4 in here, that's positive. That's okay. If I plug in negative 4 in here, negative 3 times negative 4 is 12. 12 take away 4 is positive. That's okay. So this is not extraneous. Let's see. Okay, so then we get into the problems that have 3 logs. So when we have 3 logs, we have to use our log facts. We've got 3 basic log facts. The first fact is, well, all fact, let me just say this. 2 of the facts are so that you don't have 3 logs anymore. So it lets you put 2 of the logs together and rewrite the problem as a single log. The third one is because you're not allowed to have numbers in front of your logs. So I guess I could start off with, I'll start off with 27 because I might run out of room here. Okay. So I'm looking at one side. This has 2 logs. I don't want 2 logs there. I want to combine them into 1. So in a subtraction, that means we can rewrite the log base 5 a single time and then put x over the 7. Then I have log base 5 of 3 over 7. And the whole point is make it so there's 1 log on each side like the problems below. So these cross out, and now you can just cross multiply to solve this. So if you cross multiply and solve this, you end up with x equals 3. Just go back for a quick check. You plug it in here, not negative, we're okay. That's your answer. Okay, the next one's got the 2 logs right here. So we combine these, but because this is a plus sign, we're going to have to actually multiply this together. And then you have the 2 can move up. So you have log base 3 of y squared. Now we have 1 log on the left, 1 log on the right, so we cross them out. Now, in semester 1, if you were with me, 4y plus 32, we spent most of semester 2's bell work factoring. This is the reason why. Factoring doesn't go away. When you see a y squared and then a regular y, it means you have to factor. The only way you can factor, though, is you have to set it equal to 0 first. So I'm going to subtract both things over. So I have y squared minus 4y minus 32 equals 0. And then this is a simple ABC. So you get a y here and a y there. 2 numbers that multiply to 32 and give me 4 are 8 and 4. To get a negative 4, I'd have to have a negative 8 and a plus 4. So this gives me 2 results. It gives me y equals 8, and it also gives me y equals negative 4. But we have to go back and check and make sure that we don't end up with any negatives inside of our logs. So if I start off with my positive 8, this is okay, and this is okay. So this one works out. If I check my negatives, when I put my negative in here, negative 4 plus 8 is still positive, but when I stick it right here, that's not good. So this one right here is your extraneous solution. Okay? So we've got some more logs. The only difference now is it looks like a lot of these have 2 logs. Let me start off with the one that only has 1. So when you have a log that only has 1, first of all, the log should be by itself. There shouldn't be any numbers around it. So we want that log base 8 of 3x isolated. So I got to get rid of this 3 first. So I get rid of the 3, and I have negative log base 8 of 3x equals negative 2. I also don't want that negative there. So that negative is like having a negative 1 times the log, so I can just divide the negative 1 to both sides. So now I have log base 8 of 3x equals 2. So if you have a problem that only has one log in it, you can actually just change forms. So this 8 goes like this. These two switch. So you have 8 squared equals 3x. So I'm going to bring this up here. 8 squared is 64 equals 3x. So I can just divide by 3. So x equals 64 over 3. If I plug it in, it's positive. We're good. That's not extraneous. So the rest of the problems have 2 logs. Now, when you have a problem that has 2 logs, you can cross out the logs if those logs are on different sides of your equal sign. These are together though. So we have to actually, instead of crossing out the logs, we have to compress them. So compress means write to it as 1. So you got log base 2 of x plus 2 and x minus 1 equals 2. So up here we had 2 different logs, and now we only have 1 log. When you have 1 log, you got to switch forms. So when we switch forms, the 2 goes like this, so it comes straight down, and then these 2 things switch. So this becomes the exponent, and then you have the x plus 2, x minus 1 equals that, which is 4. Now you FOIL this out, and I'm going to just do it in my head so I can save time. So I have x squared plus 1x minus 2. Anytime you have an x squared and an x, you got to factor. So you got to move the 4 over. So we subtract the 4 over. So we end up with x squared plus 1x minus 6 equals 0. 2 numbers that multiply to 6 and give me 1, 2 and 3. To make it a plus 1, it would have to be a plus 3 and a minus 2 equals 0. So that means that x equals 2 and x equals negative 3. So we have to go back and check in the original problem. Are we going to get any negatives inside of these logs? So I start off with 2. If I put a 2 here, it's positive. If I put 2 here, it's positive. We're good. We tried the negative. If I put negative 3 here, that's negative. So I can stop. That's extraneous. There's your 2 answers. The last couple are almost exactly the same. You got the 2 logs here, so we compress them down into 1. That's a plus, so that means to multiply these together equals 2. Then we change forms, so the 7 comes down. These 2 things switch, so 7 squared equals 8 times x plus 1. You got 49 equals 8x plus 8. Subtract 8 from both sides, you get 41 equals 8x. Divide 8 to both sides, x equals 41 over 8. Quick check, you plug in 41 over 8 and add 1 to it, it's still positive, we're good to go. That's the answer. Last one, finally. Log base 4, it's a plus again. So that means we can write a single log base 4 of 3 times negative 4x, and that equals 2. What do we have here? Oh, we can change forms. It's a single log. So this comes down. These 2 switch. So you got the 2 up here, 3 times negative 4x over here. So you get negative 12x equals 16. Divide by negative 12, and you get x equals negative 4/3. Again, it's not extraneous just because it's negative. When you go back into here to the 4x and multiply it, a negative times a negative is a positive. So that's actually okay. So that's your answer. I'm not doing any of the graphs, and I'm not gonna. Well, maybe I will. Let me pull up the model. I was gonna not talk about the model, but there were some people messing up in class. So let me grab the little screen cap thing and talk about this model for a second. I want to talk about the rabbit one. Let me pull up my little camera. Oh, I minimized this. Just kidding. Let me go and cut it and paste it. I'm not going to do the graph. I'm just going to answer the model stuff. You can graph it on your own. You're capable, completely capable. Okay, here we go. Let me get a new page going. So here's what I want to talk about. You have to know the difference between exponential growth and exponential decay. It says, suppose the population is 25 rabbits is introduced. Right here it says increasing. Right away, increasing. So that means that we can create the model which I think is part B. Create an exponential model. Now guys, when it says model, that means this stays a letter. I saw a lot of people putting in the 20s and the 30s and the 50s, but that's not until part C. So your model, this is the initial amount. A is the initial amount. We started off with how many rabbits? It says we start off with 25 rabbits. Oh, did I read that right? Just make sure. Yeah, 25 rabbits. This is 1 plus, and it's plus because it's growth. And the R, if you guys look up at the R is easy to find. R is easy to find because it's 14.5%. R always has the percent on it, but when we put it in the formula, it can't be in percent. So we have to take the decimal and move it to the left twice. So it becomes 0.145. So that means we put in 0.145. And then we just leave the x. And you can, I don't care if it's an x or a t, just leave it. That's the model. So the next part is now use your model to estimate, and it says t, x, whatever, it's all the same, x right there, or t, I don't care what you use. But you just have to plug in the 20, the 30, and the 50. Hopefully you stuck to the end to see this video, because I got a joke for you. I just thought of it because of the R. So what's a pirate's favorite letter? You would think it's R, but they're actually in love with the C. All right, that was whack. Anyways, we're going to try to take that test tomorrow, hopefully, if it's online. If not, we'll have to do it Monday. But hopefully you're watching the video, because I know I went a little fast, but I sucked it up, tried to do a video for you to try to help you out. So hopefully it worked. I'll see you tomorrow.